Hello guys, welcome to the next episode of Coffee with Concept, and in this crisp video I am going to talk about an important concept from engineering mathematics, an important concept from probability. And why I call it as important, because it's it's an area where frequently questions can be seen in GATE or engineering services or even other examinations, other technical based examinations of PSUs or ISRO, etc. And that is the binomial distribution. So although it is easy to understand, but it is very important, so I thought of covering in this Coffee with Concept, so that this brief video gives you enough idea about this binomial distribution. So without wasting any more time, let us get started. And first of all, to understand the base of binomial distribution, let us learn the Bernoulli's trial. Yes, what exactly a Bernoulli trial means for me. Say for example I flip a coin. What are the possible outcomes you see? Now when you flip a coin, there are only two possible outcomes, that is head or tail. Right? I make a phone call, to a person. Will he pick my call? Yes or no? Right? Yes or no? I go to visit a doctor. Will I be able to make it on time? Yes or no? So there are certain things in the world which can be classified as yes or no answer, or I can call it as success or failure. Suppose I'm able to make the phone call, success. If I'm able to meet the doctor, success. Now coin has two things, head or tail. Conventionally, we'll call head as success, just as a convention, or just as a convention. So head being the success. So there are several things. There are several trials for which outcome is either a success or a failure. All such trials will be named under Bernoulli trial. So it's a random experiment with exactly two possible outcomes. And they are the success and failure. The success and failure. And every time, whatever may be the probability of success, for each and every term, it is equal to P. Say for example, you toss a coin, what is the probability of head? It is 1 by 2. You again toss a coin, what is the probability of head? It is again 1 by 2. You again toss a coin, what is the probability of head? It is again 1 by 2. So the probability of success is same in every trial and every time the experiment is conducted. That is what basically, first of all, a Bernoulli's trial would mean to me. And we'll simply call the probability of success as P. So automatically, the probability of failure would be 1 minus P, logically, right? Now, as the example already, the first very common example that is associated with the Bernoulli's is flipping a coin, that I've already told you. Yes, when you flip a coin, you get head or tail, and here conventionally, head denotes the success. That is just a convention, You can call tail also a success, your wish. Now, can I classify, just think about this statement, can I classify a dice under this category? So many of you may think, so no, dice has a 6 possible. When I roll a dice, it has 6 possible outcomes. So it cannot be categorized under Bernoulli's, because for Bernoulli's I need only two trials. One is head, one is tail. One is the head, one is the success, one is the failure. No, it's not about, just change your way of thinking. Suppose I roll a dice, and suppose you're playing the game of Ludo. What do you want in the dice first of all to start your game? You need a 6 so that one of your players come out of the home. Right. So when you roll a dice, you need a 6. That becomes a success for you. And if anything else comes, maybe 1, 2, 3, 4, 5. If anything else comes, that is a failure for you. So I can put it like this. One way of thinking is a dice is rolled, it has 6 outcomes. Another way of thinking is a dice is rolled and it has two possibilities. One is getting a 6. One is not getting a 6. So guys, in like this, you can classify several things as success and failure. Yes, rolling a dice can also fit under a Bernoulli's trial. Right here 6 is success. This is just an example. Say this is just an example that 6 is success, and anything else means 1, 2, 3, 4, 5. That is a failure, right? So as I just told you, what is P? P is the probability of success, right? So here what would be the P? Here the P means getting a 6. And since let's assume a fair dice, the probability of getting any one outcome, is equal to 1 by 6. So probability of failure will be, of course, 5 by 6. That also we can see. Now this is what you should know about a Bernoulli's trial. Now let's have a look into the binomial distribution moving ahead. The binomial distribution, where a Bernoulli's trial is repeated independently n number of times. independent repeated trials of Bernoulli becomes binomial. Again, let us understand with example and then generalize. Okay, so firstly, to take up an example, I again start with a very common case, that is the coin. Okay, the coin with suppose probability of head equal to p. Now you might think the probability of head is 1/2. Okay, but it may be unfair coin or it may be any other situation, because later on I will call this probability of head as probability of success. Okay, so we are going to generalize what we learn from coin. Okay, let us learn with respect to coin. It is easy. A coin with probability of head equal to p is tossed repeatedly and independently n times. Okay, so why coin tosses are independent? As I just told you, a few minutes back also. Let's listen to one more example. Okay, suppose you toss a coin. Okay, you obtain a head. Listen to me. You toss a coin, you obtain a head on the first trial. Now you again toss a coin. What is going to be the probability of head? Next time when you toss again, it has 50% chance of head and tail. So next time it is again 1/2, 50%. Suppose you have tossed a coin 4 times and luckily for all 4 times you got head. What is the probability of head on 5th? Does it mean that the last 4 were heads, so it is a habit, it is a pattern that head will only come? What is the probability next time? 50-50 chance head or tail, matlab 1/2 again. A coin is tossed and 100 times luckily it has comes up head. What is the probability of head on the 101 toss? It is again 50% only. So that is why the coin tosses are independent, and that independent trials fit into the binomial. Okay, why it is independent? Because whatever has happened in the past, maybe 4 heads, maybe 100 heads, still it cannot decide what is going to happen next. Okay, it cannot decide what is going to happen next. Okay, so this is one of the example of binomial distribution. Now moving ahead. Okay, let's talk about some more parameters. So a coin is tossed repeatedly and independently n times, and now let us measure how many times heads have obtained. Okay, number of heads will correspond to, in general, number of successes. You do an activity n number of time. Okay, you do an activity n number of time. You do an activity n number of times. How many times you have got success? That is what X is. How many times you have got success? So let X is the number of heads and number of success, because traditionally head is here used to represent success. Okay. Now first of all, how many times heads may come? Okay, if you are unlucky, you have tossed it n times. Okay, you have tossed it n times. You are unlucky, you have not got even a single head. All are tails. Possible, na? Or maybe 1 head, or maybe 2 head. Or maybe you are very lucky, you have got all heads, all success you have got. So the range of X will be from 0 to n. Okay, it can be minimum 0 or maximum all heads. That's what, it cannot go beyond than that. Okay. X then is known as a binomial random variable or binomial distribution. Why it is binomial? I'll just going to rectify that also. So X is known as a binomial random variable with the parameters of n and p, where n is the number of trials and p is the probability of success on a single trial. Okay. Now, what is its probability calculation? PMF, the probability mass function. Okay. So we know what do we calculate in probability mass function. Okay. If I say PMF is PK, it simply means that what is the probability that the random variable X takes the value K. What is the probability that random variable takes the value K? Now, what is that random variable here? X. What is that X random variable? In X, I am counting the number of success. I am counting the number of heads. Okay. So if I say X equal to K, that means I am calculating the probability of getting K heads. I am getting the probability of K heads out of n trials. What is the probability you have got K heads? So very logical, right? It is also equal to, if you have got K heads, na dear, if you have got K heads, what are the remaining? Out of the n, the remaining are automatically tails. That is what is the beauty of Bernoulli's. The Bernoulli's trial, because every single outcome has only 2 things, head or tail. Okay, so if K times head, remaining time, there is no other option, it will be tails. So remaining all n minus K is tails. Now everybody dear, I can write down what is the probability that X equal to K. What is the probability of single head? Let us say P here. Don't take 1/2 right now. Right. So single head probability is P, but that head is coming K times. So P into P into P into P K times. So P raised to the power K. What is the probability of a single tail? That is 1 minus P. Probability of failure. How many times tail? Okay. N minus K. So 1 minus P will get multiplied n minus K times. Okay. Is that the only formula? No, not at all. Not at all. If you think, I've just told you k heads should come. But where are the k heads? In the beginning, in the end, somewhere in middle, or alternate. Yeah, 2 at a time, then a tail, 2 at a time, and then a tail. It can take any pattern. It can take any pattern. So, you have to select any k positions for heads out of n, and that selection is represented by, nck. Okay, the selection is represented by nck. This is used to select any k positions for heads out of n. Any k positions for heads out of what? Out of the n. nck p power k 1 minus p raised to the power n minus k. Okay, so this is what is the PMF formula. Yes, nck p power k 1 minus p power n minus k, where k, as I told you, k is the number of heads, and that can be from 0 to n. Okay, also make a note that the mean of this distribution is n into p, and the variance is np 1 minus p. One more thing, commonly, as I told you, 1 minus p, we can also write the 1 minus p as, okay, we can also write the 1 minus p as q. So this is nck p power k q power n minus k, where p is the probability of success and q is the probability of failure. Q is 1 minus p, which is failure probability, right? Okay, so it can also be written as nck p power k q power n minus k. Correct? nck p power k q power n minus k, and that is why even if I go to variance is npq, and mean of the distribution is simply equal to what? The mean of the distribution is equal to n into p. Okay, the mean of the distribution is equal to the n into p. Just a second. Yeah, sorry, where is that gone? Oh, it is not appearing here, unfortunately. Okay, that is npq. Now guys, the next important thing to note is why this was named as a binomial distribution. Why such a probability calculation was known as a binomial distribution? Have a look into a very simple logic behind this. That what is this nck p power k q power n minus k? The nck p power k q minus n power k represents the general term of binomial expansion. This is the general term of any binomial expansion. General term of any binomial expansion. Okay, just to give you the feel, let me write it here. Okay, p plus q raised to the power n. What is p plus q raised to the power n? nc0 p power 0 q power n. Right? Okay. nc1 p power 1 q power n minus 1. Okay. Next, nc2 p power 2 q power n minus 2, etc., up to last term, ncn p power n q power 0 q power 0. Okay, so nc1 p power 1 q power n minus 1, nc2 p power 2 q power n minus 2. It is just like nck p power k q power n minus k. This is what is the binomial expansion. This is what is the binomial expansion. Okay, so the PMF formula that is derived, is representing the general term of a binomial expansion that you learn in your very high schools only. Okay, and hence this is known as a binomial random variable or a binomial distribution. Okay, not only this, okay, it is always better to have the understanding with the help of question. Okay, so let's take a particular question here. Okay, a fair unbiased coin, okay, is tossed 15 times. Okay, so coin, as I told you, is a Bernoulli's event. Okay, it is tossed how many times? N. That is 15. What is the probability of getting exactly 8 heads? Now, if you solve this without binomial formula, if you solve this by sample space, it's going to be very lengthy, because sample space for 15 coins will contain, for 15 trials will contain 2 power 15 samples. Okay. Now, what is the probability of getting k heads? Okay. What is the probability of getting 8 heads? So, k is equal to 8. K is equal to 8 success. Okay. K is equal to 8 success. Tell me what should be the formula. Now, it is a fair coin. What I can do is, for a fair coin, let me do one thing here, everybody. For a fair coin, because it is a very repetitive question, for fair coin, let me generalize the formula. Okay, so for fair coin, we know what is the probability of head. It is half. Okay, so of course, Q is also half. Probability of tail is also half. So what is going to be the formula? Okay, then the formula pk looks like nck p raised to the power k. P is half. Okay, then p raised to the power n minus k. So half is common, so take the power k plus n minus k. K will get cancelled. So you have p of k, that is simply nck half raised to the power, only n will be left. nck half power n. So that you can specially use for fair coin, because fair coin is a very common question, with respect to the examination. Okay, so let me come back to the question. So what is the probability of getting the exactly 8 heads? Okay, so probability of k equal to 8 should be equal to how much? The formula that I'm going to use is the formula that I just wrote. पहले उसको use करेंगे. Okay, that is probability of k for fair coin. It is nck half power n. For what? For a fair coin, right? So what is the probability for getting k heads, right? N ka value 15 है, it is going to be 15c8 into half raised to the power 15. Okay, and I've put it as a numerical answer type question. You can solve and give me the result. Okay, you can just solve and give me the result. Everybody can just solve and give me the result quickly. Acha, not only this, you can write down the 15c8 as 15c7. Okay, then half raised to the power 15. Okay, let's do up the calculation quickly and let's write down the answer. Okay, so hope you have done the calculations, and approximately the answer that is turning up solving this calculation is 0.196. It's an NAT type question, and I've written the answer up to 3 decimal places. Okay, they've mentioned up to 3 decimal places, so I've written up to 3 decimal places. Moving ahead to the next question now. Let's move ahead to the next case then. Okay. The probability of obtaining at least 2 6. Now, I told you the dice can also be fit here in throwing a fair dice. Okay. So, when I talk about a fair dice, it can have 2 outcomes. Actually, it has 6 outcomes, but I am looking for at least 2 6. I am looking for 6. At least 2 or at least 3, wo baad mein dekhenge, but I'm looking for 6. So, let's say I have a 6 as my success. So, when a dice is tossed, it may have a success, right? Or it may have not the success. Okay, it may have a 6, it may have not a 6. Okay, this 6 here is success for you, and not a 6 is a failure for you. So number 1 point, what is P? As we all know, P is known as the probability of success, and probability of getting a 6 is 1 by 6. So what is Q? Q is 1 minus P, that is 5 by 6. Okay, now I need at least 2 6. Okay, what does this statement says? You need at least 2 6 means at least 2 6 means at least 2 success. What you're looking for is at least 2 success. Okay, that means K is not only 2, it is 2 or greater than equal to 2. At least 2 success. So K greater than or equal to 2. Okay, so let's solve it up now. Let's solve it up. Probability K greater than equal to 2 means probability K can be 2 or K can be 3 or K can be 4. Okay, why to do 3 calculations? Okay, what is the total range of K? What is the total range of K, right? We know that K can be from 0 to N. 0 to N. What is the value of N here? Okay, 4 times the dice is tossed, so N is equal to 4. N is equal to 4. So why to do 3 calculation? Better is 1 minus the remaining calculation, P0 and P1. 1 minus P0 plus P1. It will be only 2 calculation. Now what is PK actually? What is PK? In general, NCK, P power K, Q raised to the power N minus K. NCK, P power K, Q power N minus K, and that should be equal to how much? N is equal to 4 here, right? So 4CK, let me put down the values first of all. 1 by 5 raised to the power K, and Q is 5 by 6 raised to the power 4 minus K. Okay, so when I put down these values here, I am getting 1 minus, dear, what is P of 0, right? 4C0. 1 by 5 की power 0, that will be 1. And then 5 by 6 की power 4. Plus next is 4C1. Put down K equal to 1 for P1. Right. 1 by 5 raised to the power 1. 5 by 6 raised to the power 4 minus 1. That will be 3. Okay. So how much is this calculation equal to? इसको separate रखते. So this is 1 minus 4C0 1. 1 by 5 power 0 is 1. So I'm left with 5 power 4. Right. Divided by okay, ये हो जाएगा 4, ठीक है, this is 5 power 4 divide by 6 power 4. Okay, this was 1 by 6, I'm sorry, this is 1 by 6. Why I have written here 1 by 4? It is a typo error here. So denominator is 6 power 4. Here it is 4 into 5 cube. Again, denominator is 6 and 6 cube. So 6 power 4. Okay, so 1 minus 5 power 4 is 625. Okay, 5 power 4 will be 625. 5 cube is 125. So 4 times 125 is divided by 6 power 4, and that is 1296. Right. So 1 minus this becomes 500. 1125 is divided by 1296, and that is going to be how much if I just take the difference between them? Okay, that is how much? 75, 175, 171. 171 by 1296 is the answer. 171 by 1296 is the answer. 171. Okay, so it's 19 by 144. You can simplify it. It will turn out to be 19 by 144 when you cancel it with a factor of 9. Okay, so 19 by 144, B is going to be the correct answer. So not only dice, it can be applied to coin or dice or any such questions. And guys, if you have really understood the concept, if you have really got hold of the concept, you should be able to answer the 2 questions that I'm giving you as homework in the comment box. Yes, guys, you have to take 2 questions as homework, and unbiased coin is tossed infinite number of times. But what is the probability that 4th head appears on the 10th toss? Only one small language you have to catch. 4th head is required on the 10th toss. So just think, hint is, if 4th head is on the 10th toss, so what has happened in the first 9 tosses? This is the hint. What has happened in the first 9 tosses? Okay, next, one more homework. This is homework number 1. Do mention your answer in the comment box. Okay, and this is going to be your homework number 2. The probability that a screw manufactured by a company is defective. So that is what, when a company manufactures a screw or any product, it may be defective or non-defective. So 2 cases are there. When 2 cases are there, matlab individually it's a Bernoulli's trial. Okay, so now read the question yourself. This is homework number 2. You have to give me the reply in the comment box. Okay, that's it from my side. I hope in this very small video you have got the basic concept of solving the binomial. This was not a question practice session, otherwise I could have brought more questions. The idea was in a small time to show you the concept, how the binomial comes up, what is the exact formulation, and then just 1 or 2 questions randomly I have taken. Okay, so you just have to practice more, but I think concept can be taken from this video. Bye bye, thank you, stay safe and take care of yourself.